So having seen that, we proceed to our next homologous family, which is alkanoic acids. Alkanoic acids. Alkanoic acids are also called carboxylic acids. The first member of the group is called methanoic acid with the molecular formula HCOOH. Other members of that family include ethanoic acid, propanoic acid, butanoic, pentanoic acid, etc. Arcanoic acids are characterized with the position of a functional group, which is COOH. So the functional group of arcanoic acids is COOH. And they have a general molecular formula of CnH2n plus 1 COOH. So COOH is like a constant parameter for arcanoic acids, just like we have just seen in alkanols. OH is a constant symbol for them. So similarly, arcanoic acid have COOH as a constant value or parameter for these compounds called arcanoic acids. And they can also be written as CnH2n plus 1 COOH, where n is greater or equal to 0 this time around, not 1, but 0. Arcanoic acids are also called carboxylic acids, we've said that, and their names are derived by replacing the last letter E in alkanes with oic acid. Oic acid. So E in alkanes, when they are being replaced with oic acids, we have the compound called alkanoic. So like before, let us proceed to learning how to write the molecular formula of these compounds called arcanoic acids. So we begin with the formula CnH2n plus 1 COOH. This is arcanoic acids. And we are told that n is greater or equal to 1. 0. Beg your pardon? 0. If that is so, it implies that the first member of that family is going to be C bracket 0 H into 2 bracket 0 plus 1 COOH. And we have it as C times 0 is 0. It goes away. H will be written down. 2 times 0 is 0. 0 plus 1 is 1. Let's just pen down 1. Then COOH. But we know in calculations, in mathematical calculations, we don't have anything like 1x. So just like we don't have anything like 1s or 1a or 1b, we just simply have a, x, or b. So since that is what it implies, it means we're not going to write down H1, but we're just going to say H, COOH. So this is the molecular formula for the first member of that family, which is methanoic acid. This is formula for methanoic acid. The next member is going to have 1 as the value for n. So this is going to be C bracket 1 H 2 bracket 1 plus 1 COOH. So this is C times 1 is C. Pen down our H. 2 times 1 is 2 plus 1. That gives us 3. And we have COOH. COOH is a constant value for all the arcanoic acids. So this is called ethanoic acid. Dear students, I'd like you to understand that when we have one carbon atom in a given compound, a given hydrocarbon compound, it goes with the prefix met. Met is attached to it. When there are two, it goes with et. The prefix et is attached to it. As we can see here, we have just one carbon atom, but here we have two carbon atoms. So it is applicable to all the homologous series. We have seen alkenes, alkynes. We have seen alkanols. Now we are looking at Arcanoic acids. So just have it at the back of your mind that the presence of one carbon atom goes with the prefix met. Two carbon atoms is et. So it means 1C is met, 2C is et, 3C is prop, 4C is but, 5 carbon atoms is hex, I beg your pardon, pent. 5 carbon atoms is pent. Pent. 6 carbon atoms is hex. 7 carbon atoms is hept. 8 carbon atoms is oct. 9 carbon atoms is non. And 10 carbon atoms is dec. So, depending on the homologous series, we can go on and on. 11, 12, 13, 14, 15, 16, 20, 30, 50. But for the knowledge of starting from the beginning, this is just our starting point. Let us take it step by step. As we go deep down into organic chemistry, you will get to know the names of the higher hydrocarbons, the higher hydrocarbons that have more carbon atoms. So if it is for alkane family, this is just going to be N continuously. You see? So that is actually what it's going to be. If it is for an alkene, the N will just be replaced with ENE, and that is how it goes. If it is an alkyne, the ANE for alkanes, will be replaced with the last letters for alkynes, which is YNE, yine. So it is going to be hexyne, heptyne, octyne, nonine, decyne. And if the homologous series, if the homologous family is an alkanol, we simply say that for alkanols, the E in alkanols will be replaced with all. So in this case, we're going to still have AN-all. AN-all. AN instead of E, all. AN instead of E, all. AN instead of E, all. So this is how organic compounds are named. 5 carbon atoms is pent, 7 carbon atoms is hept, 6 carbon atoms is hex, 3 carbon atoms is prop, 8 carbon atoms is oct, 1 carbon atom is met, and it continues that way. Those are the prefixes so that we get to understand how to name these hydrocarbons. So having seen the molecular formula for Arcanoic acids, let us take a look at the structural formula. We are going to consider how to write the structural formula for Arcanoic acids now. So let's proceed. For Arcanoic acids, let us look at the structural formulae for Arcanoic acids, or some members of the family. So we have alkanoic acid, alkanoic acid. We have the molecular formula, structural formula, condensed formula. I have condensed formula. So the first member is metanoic acid. Metanoic acid with the molecular formula HCOOH. The structural formula will be COOH and H. This is how the structural formula for metanoic acid looks like. To make it very clear, let us put down this way so that we can get to understand. Oh, don't forget, we have said that carbon must always have 4 bonds. So since carbon must always have 4 bonds, we have 1 bond here, 2 bonds from OH, and carbon is having 2 from oxygen, which is 1, 2, 3, and 4. So carbon is having 4 bonds, 1 from hydrogen, 1 from OH, and 2 from oxygen. So that is how the structure for metanoic acid looks like. And the condensed formula for that compound will simply be the same way it is, HCOOH. That's the condensed formula for metanoic acid. Let's take a look at the second member, which is ethanoic acid. Ethanoic acid. Ethanoic acid. Ethanoic acid is CH3COOH. So there are 2 carbon atoms there, C, because it is not an unsaturated compound. It is saturated. The carbon atoms are saturated, not unsaturated. So we have C, and here we have the 3 hydrogens attached to the carbon. Now we have a double bond to oxygen and OH. This is how the structural formula for ethanoic acid is written. This is how to write the structural formula for ethanoic acid. And the condensed formula is the same, CH3COOH. CH3COOH.